Okay, our goal in the previous few examples were to define a sub n by n so that each term could be found independently from the other terms of the sequence. But that's not always possible, all right? And where it's not possible are in things called recursive sequences, all right? Once you're given the first few terms, all other terms are defined using previous terms. So recursive means if you needed to find the 100th term, you need the 99th term. Whereas if you have an explicit formula, like in the previous video, let's say a sub n was 2n minus 1. All right, if I wanted to figure out what the 100th term was, I could just plug in 100 in for n. All right, with recursive, you can't do that. You would need the 99th term to find the 100th term. So the most famous example of a recursive function or sequence is the Fibonacci sequence. All right, so let's look at its definition. It says a sub 0 is 1 and a sub 1 is 1. All right, with recursive sequences, you're always going to have the first couple terms given to you, all right, because you need those to find the next term. So we need the 0th and the first term to find the second term, and the first and the second term to find the third term, and so on. All right, then the definition. So it says a sub k is equal to a sub k minus 2 plus a sub k minus 1. So you could think of a sub k as like the term you're on currently. So if this was the 10th term, then a sub k minus 2 is 2 terms prior. So that would be the 8th term. And a sub k minus 1 would be 1 term before a sub k. So that would be the 9th term. So let's use this formula here to find the first 5 terms of the Fibonacci sequence. All right, so the first 2 are given to us. All right, the second term, all right, so 2 is k, that's the term number that we're on. We're going to plug k right into these parts of the formula here. So you see that a sub 2 is equal to a sub 0 plus a sub 1. Then you take a sub 0 and you replace it with its like the value for that a sub 1. And you plug in the value for a sub 1 in for a sub 1, and you get 1 plus 1 is 2. All right, so then a sub 3, okay? A sub 3 would be a sub 3 minus 2 plus a sub 3 minus 1. So we literally just replace k with 3, and it simplifies down to a sub 3 is equal to a sub 1 plus a sub 2. Now I'm going to take a sub 1 and plug it in right there, and a sub 2 and plug it in right there, and I get 3. Okay? If I keep going, a sub 4 is going to be a sub 4 minus 2, which is a sub 2, plus a sub 4 minus 1, which is a sub 3. Okay? A sub 2 is 2, a sub 3 is 3, so we get 5. So the fourth term is 5. Okay? Then we can go ahead and do a sub 5. A sub 5 would be a sub 5 minus 2, which is a sub 3, plus a sub 5 minus 1, which is a sub 4. Now I take this third term and replace it with 3, because that's what the third term equals, and add it to the fourth term and replace it with 5. And then I get 8. Alright, pause the video real quick and see if you could do the next few terms. Okay, here they are written on the side. So you can literally just, this formula here just means take the 2 previous terms and add them together. So we get, okay, 5 plus 8 is 13. So that's how I got that number. 8 plus 13 is 21. That's how I got that number. 13 plus 21 is 34. All right, and so on and so forth. So real quick, let's finish this video. Let me show you how to do some of this on a calculator. You know what? I think I'm going to run out of time. I'm going to make this the next video. I changed my mind.